years. We are locally owned and operated by the Stevens family. We not only clean carpet and furniture, we clean many loose rugs, including Oriental rugs. Oriental rugs are cleaned in our modern facility where the fringes are cleaned by hand, then hung in our modern facility to dry. We do not use steam cleaning to clean your fine furniture. Furniture is cleaned by hand using the same absorption cleaning used in the White House. Some furniture we bring into our plant to clean properly. We normally use 2 men on each cleaning job using the extraction method. There is nothing that will clean carpet better for our customers. Our job is to clean properly with quality first. Google Carpet Masters San Bernardino and give us a call, or go to carpetmasterssocal.com.
Look around your office. Is it time to change things up, start a new home office, or reorganize your professional office space? Visit Office Furniture Outlet in Corona, and you'll feel great. With a huge inventory of both new and pre-owned office furniture, you can buy, sell, or even trade to get the job done. Office Furniture Outlet in Corona will get you looking and feeling good, and that simply means success and great business results. From executive office collections to home office options, you can find exactly what you need at an affordable price. Office Furniture Outlet. They have desk selections that range from modern and contemporary to traditional and elegant. With a large selection of sizes, finishes, and styles, you can design an office just the way you need it. An office you can be proud of. The Office Furniture Outlet in Corona is just south of the 91 freeway in McKinley at 284 DuPont Street, or visit ofousa.com. That's ofousa.com for the Office Furniture Outlet in Corona today.
A superior nutritional supplement called Arbor Vitae has taken Australia by storm, and it's now available in the U.S. Arbor Vitae contains a unique combination of maritime pine bark, aloe vera, honey, and an enzyme from papaya seeds. This potent supplement was developed to impact inflammation in the human body. Arbor Vitae helps blood circulation and respiratory function. Its anti-inflammatory properties can also relieve minor muscle and joint pain. To order, log on to ARBORVITAEUS.com or phone 1-800-570-0433 and enter code KCAA at checkout to receive a 10% discount. Arbor Vitae is Mother Nature's helping hand. Order this unique supplement now. Call 1-800-570-0433 and mention that you heard it on KCAA to get a 10% discount.
Do you want exposure for your business or organization? Check out Digital Network Advertising. Digital Network Advertising is where businesses display your ad inside their building. You can choose your marketing sites or jump on the DNA system and advertise with all participants. Your slide holds the virtual billboard for 14 seconds and is displayed 3 times an hour. It's a novel way to be seen, be discovered, and to be remembered. Digital Network Advertising with networks in Redlands and Yucaipa. Call 909-222-9293 for introductory pricing. That's 909-222-9293.
You've tuned in to KCAA, the station that leaves no listener behind.
Live from the NBC News radio broadcasting studios of KCAA 1050 AM. I can't get these today. 102.3 FM and 106.5 FM, located in beautiful California. Thanks for tuning in. I'm Rob Starr, along with Mr. Mike Barron. How you doing? He's the man you talk about, the man you see about, the man you want to know about. Mikeypedia Mike.
All right.
And I'm laughing because of our what's happening today.
You were talking about Mike.
There's 2 mics here today.
Mike squared tonight.
Mike squared today. And I don't know where when we see you, we start to laugh. I guess that's what we were talking about yesterday and today in our office and stuff. But also, we're talking about glue today. So
cement, not glue.
Yeah, glue. That's right. We got to clean.
There's not a cow in the front of this.
That's right. We got to do that. Anyway, for anybody that's listening in, now today is a special show. What we're doing is having a training session that we do for the Irrigation Association. And what's neat about that is anybody who's a professional landscape irrigation contractor or a professional in that business and belongs to the Irrigation Association. They can, once they hear this or view it, because you can watch this on www.kcaa.com, and you can do it also on Ustream. What you do at the end of the show or tomorrow, you call or send an email into the Irrigation Association. We're going to give you a code that you give them, and then you get continuing education units. So we do this once a quarter. This week we have a great guest and a great product that they're going to be talking about and teach you how to use it, which may seem simple to somebody, but it's really more complicated than just going to a store and buying a can of PVC cement, and correctly that was what you told me, and it's not glue. A lot of regular people just call it pipe glue, but that's not the real name. What we have here today is Mr. Mike Grabowski.
Grabowski. 3 words.
I should cement that all together and do that. He's the technical educational manager for Weldon, and Weldon's one of the Water Zone's sponsor. We're very proud to.
We want to thank you for that.
Absolutely,
quite welcome.
And
we love being part of it.
We had your president and CEO on a couple times, and we learned a lot about him. Like, he's a famous race car driver and all kinds of other things, and very nice and smart man. So we appreciate that. What we're going to do today is turn most of the show over to Mike number 2, and he'll go through a presentation. It's pretty interesting because everybody thinks when you get to broken sprinkler pipes and things, you just go do little things, and it's really more complicated than if you want to do the job right. Everybody does it quick and fast.
It's just really knowing about the basics and
the choices,
applying the technique, the correct technique.
Yes.
And once you do that, you're going to have a more secure irrigation system,
right,
and less wasteful.
Yeah, and you know, you go to the store and you see all kinds of PVC cement. You see stuff that takes a primer, things that don't take a primer, things they say is instant this and that, and how do you know which one to buy? And then how do you store it, and how do you use it? And then what about the doppler that you got to use, and things like that, and how do you apply it? Most people take it, they slop it on, put it together, and then they turn it on right away. Well, there's a waiting period you should do to make sure it
There's
does.
a waiting period?
There's a waiting period.
That may explain a few things.
Yeah.
Drum rolls, huh?
Yeah, and there's all different kinds
Ear
of tools.
cleaners are actually both sides, depending on what you got in there.
But I think what we'll do, I want to play a commercial that Weldon has, and then we'll get into this and give them the floor. And anybody who wants to call in, please do so, because this is a learning session. So anybody out there that has a question in the middle of this or at the end, please do so. It's 888-909-1050, or if you're local, 909-792-5222. And so let's listen to this quickie commercial, and then we'll get into the meat of things.
Did you know that an irrigation system that has a leak of just 1/32 of an inch in diameter, that's the thickness of a dime, wastes 6,300 gallons of water per month, or 75,000 gallons per year? Well, with more solvent cement experience than anyone on the planet, Weldon formulates their products not just to meet a standard, but to exceed it. Weldon products are designed to provide even greater safety margins, often able to make up for common mistakes or less than ideal installation conditions, reducing the chance for leaks and costly callbacks. Weldon's invention of solvent cement over 60 years ago revolutionized the piping industry. From day one, Weldon has led the industry with their broad range of high-performing solvent cements, primers, and cleaners, bringing unique solutions to professional contractors and homeowners. Along the way, Weldon has earned the loyalty of millions of professional contractors who trust their products and depend on their outstanding customer service, live technical hotline, troubleshooting services, and free training. And because they care about the environment, Weldon was the first manufacturer to develop and offer a complete line of low VOC cements. Their hottest formulation is Weldon 750 Hot Weld, a one-step, fast-setting blue PVC solvent cement specifically formulated for superior, long-term, trouble-free performance. So whether you're a professional contractor or just a backyard do-it-yourselfer, choose Weldon, the trusted global leader in solvent cements for leak-free plastic piping systems. To learn more about their complete line of products or technical training, visit the web at www.weldon.com or call their technical service hotline at 877-477-8327.
Hey, welcome back to the Water Zone with Mike and Rob today, and hope everybody's having a great day. Again, we have Mr. Mike Grabowski. He's the Technical Education Manager for Weldon, and we're going to turn this session over to him, and we're going to be serious now. I won't try to be funny because I do have a real job, and maybe
You'd
I
like to keep it.
Yeah, and I shouldn't be funny at work either. So.
You can't help it, Rob.
No, we try. We have some good laughs.
Yeah.
Mm-hmm.
We have some
And we
good
do some
laughs.
hard work.
Yeah.
Okay.
And now we have our special Weldon hats on.
That's right.
So that's a good thing. So let's turn this over to Mr. Mike Grabowski.
Okay, by the way, if
welcome
you guys,
to the show.
Oh, thank you very much for having us. If you have any questions whatsoever, please feel free to chime in, and you guys too. Don't forget, if you guys have an issue or you guys have a question,
Are
you guys can get
there
in.
any free samples from tonight's program? No, I'm just kidding. I'll let you go.
For his Halloween bag?
I got mine.
Could be for his Halloween
We'll
bag,
take
right? All right. Everybody out there online, you can probably see right now we should have a graphic up there. There you go.
Aha.
All right. And for those of you that are not watching this by video, I'll try to be as forward as I can so you guys can use inside your brain what I'm saying. And sort of picture it anyway.
Transparent like your cement.
Yeah, exactly, exactly. Let's first get to what Rob said about when you go to the store, or Mike was saying when you go to the store and you look and you just say, hey, PVC cement, we're going to grab it. That's it because it says PVC, and then you get home and you put it on your pipes and you find out, guess what? You got leaks and you're wondering why. Did you ever read the back of the can? And that's the biggest thing. When I do many trainings, and one of my first questions I ask people, how many people here have actually read the back of the can? And believe it or not, less than 1%.
Well, they say that real men do not read instructions.
I call it the testosterone system. I'm sorry. I call it the testosterone syndrome. But if there's women inside there, I always call it the IKEA syndrome. Because did you ever go to IKEA and get something from IKEA? What do, right? Nobody ever looks
You
at
just try to put it together.
Exactly, and you end up with 3 screws left over.
I go there for the Swedish meatballs. They're really good.
You got 3 extra screws left over there too in the back. What do you do, right? Something's wrong. They just taste kind of crunchy.
Yeah.
But anyway, yes, one of the biggest things actually is making sure that you got the right cement. Okay, so you definitely want to make sure that you guys are reading what's on the back of the can. Here, actually, what we're doing, we'll get to that in just a couple seconds. But again, of course, my name is Mike Grabowski. I do work for Weldon. They're a wonderful company to work for. We've been around for 62 years. Actually, we are the innovator. Yeah, actually, back 62 years ago, there's a few guys that got together and said, hey, we got to put this plastic pipe together, and said, hey, guess what? Let's try a couple ways. And what they did is they used solvents. And solvents.
They didn't have duct tape then?
No, I guess not, right?
So that's like 1955, something like that? 56, yeah.
Don't have a calculator,
Yeah,
but in my head it had to be.
Before
right.
1960.
Right. I had 62 minus, what is this, 17?
Yeah.
Oh, so that'd actually make it even. That would actually be
57, I think. No, 55.
55, 65, 75, 85, 95, 05, 15. Yeah, very good. I use my
That's
fingers
a long
for that.
time. That's pretty good.
Yeah, it's actually not that bad. But anyway, so what they did is this: they tried playing around with things, and then they found out that the best way to do this is melt a pipe. If we melt it together, guess what? We're gonna have a great bond, right? So that's why it's not glue. We're not actually gluing anything together. What we're actually doing is we're actually gonna melt the pipe together. Kind of strange, right? And that's why this is called solvent cementing. All right, because solvents do 2 things. They melt things and they evaporate. Okay, so keep that in mind. They melt and evaporate, melt and evaporate, melt and evaporate. And if you've been one of my class members at all, you guys know that I say that about 100 times during the class, because that's exactly what they do and exactly what we're going to do. Okay, excuse me. All right, so that's the biggest thing about on the back. Like I said, you want to make sure that you got the right cement, because it's not just like a glue to throw it on. Okay. But anyway, yeah, so I've been there for a few years. I worked in a research and development department for a few years as well. And we have a great staff. I don't know if it's okay to mention any names or not. But,
Sure.
But and our technical department, Beverly, she's been around for a long time. She's the one that you guys call, and you guys get the 800 number. She's the one that answers the phone, and she knows pretty much all when it comes down to, having an issue. And then when on our East Coast side, we have Jack Roach. He's actually the main mechanical engineer, if you want to call it that. This guy knows everything about pipe and fitting that you would possibly ever think of. And then Terry McPherson, he's right in line on the top right there. Those are the top dogs right there. And then you got us Army guys. That's myself, and I go from the Mississippi River to Hawaii. And then Stephen Gardner, he does from the Mississippi River to the islands, so he goes the opposite way. And Van Hester, he also does pretty much, he covers everybody because a lot of people are on vacation or we get overloaded, so he flies around a real lot. And then Joe Lovingood. He's the man, and he takes all the samples after we make samples actually in some of our classes for the B31.3. I'll explain that in a little bit. But we actually have our guys make samples and send them in, and we actually put them under pressure. And then they get their qualification cards for ASTM and ASME.
So when you say samples, you mean like they take 2 pieces of pipe and they apply the cement, and they have to apply the proper technique, and then you actually will assess the integrity of that welding?
Yes, sir. Actually, yes. We actually, when we come out, we actually go out to the companies, and this is a free training. It's kind of cool too. We actually come out to your place, to the construction site. Even I've actually done it on the inside of our construction trailer, or what they call the storage container. Out in Tesla, they're still building their plant out there, but they didn't have any walls to put our projector on. But yeah, we bring a projector out there. We do it about an hour and 15-minute PowerPoint. That's with questions and stuff. And then what we do is we actually have people. Now this is all ASTM, all right, standard. And then we do the ASME, which is the American Society of Mechanical Engineers. They have a standard as well, okay? Now you can actually get qualified and get a qualification card. And the qualification card looks just like this. I know you can't zoom in on this, but anyway, what we do is we have you guys make a sample, and it almost looks like a pipe bomb, okay? I don't know if I could say that on here, but anyway, it's an 11-inch piece of pipe, all right? And we have you guys cement a cap on both sides, all right? We have holes drilled in the end, of course, so you can get it together. Otherwise, if you having pressure, you won't be able to get it. I can't get this one on, right? But anyway, after with the PVC, what we do is we take the samples, and then we have a hydro lab. Our own hydro lab we do really crazy stuff out there, really good stuff. That's actually where Joe Lovingood comes in. He comes out there, and then we actually take them after 14 days. They have a set time, all right? And we take them, and we put them under pressure. Now there's a curve to how much pressure we use because ASME has a standard of the sample size needing to be a certain percentage of your biggest pipe being made. So it's different. I've just had guys, where was I just at, that just did 6-inch samples in diameter. And then you got the guys that are out on the field doing the irrigation. If they do a 2-inch pipe, all right, because it has to be 25% of the largest pipe. So if I come out to the irrigation site and we train you guys, and we have you guys make 2-inch samples, 14 days later they go under pressure. If they pass, then you guys will get your card. That'll actually qualify you to go up to an 8-inch pressure pipe, because you got 2, 4, 6, 8, 25% of that. In
your experience, if you take the basic homeowner who does this.
Yes, that's me.
Okay, yeah, but you're more experienced. What percentage of those do you think, with what they do in fixing pipe, would achieve a passing grade?
Or certification?
Yeah.
Are you talking about right now, before or after the class?
Before.
Before the class?
Yeah.
Seriously?
So really, how many people are doing it wrong?
Well, how about, I can tell you a really fast story. How's that? Where did you learn to put your first pipe together? I mean, we all had to put a pipe together at one time, the first time. Where did you see that? You saw somebody, either your grandfather or your uncle or your cousin, all right? Now, you didn't read the can. You sure hope he read the can. And then he hoped the person before him read the can. And that's where the ASTM came along, because ASTM, of course, makes the standards. They, circled it out and said, hey, guess what? Let's take a look at this, and everybody write down what the best way is. And they started crossing them out, said, okay, this is the best way right here. Let's start testing it. Then they started testing it and testing it and testing it. Then guess what? This works. Let's put it on the back of the can. Make it a standard. So if you take even a look at our competitors' cans as well, you're going to see It's really, really, really close. So this isn't like Weldon's way of saying, hey, we're telling you to put pipe together this way. This is actually ASTM, all right? And then the ASME is on the other end of it with their test,
Right.
you know, to have your qualification. And that's actually it's just called the ASTM B31.3. Now the ASME B31.3. Those numbers are in my head. But anyway, what's happening across the United States, and it's happening a real lot actually, is the contractors, lead contractors, and the architects, they're starting to spec this into the job, saying, guess what? To work on my job, to work on these jobs, we want you guys to be ASME B31.3 qualified to have that card. All right. Now, well, think about this. Would you rather have a group of guys that's going to work for you, all right, that have never been trained and never passed the test at 700 PSI? Now, imagine your house is what, 60, 65 PSI, 80 PSI on a good shower day, right? So figure we're going to take that sample. After 14 days, we're going to jack it up 10 times, 11 times, 12 times the house pressure. Okay, would you rather have a group of guys that took this course, went through the course, passed this test, or a group of guys that have never even read the back of the can?
Good point.
Exactly. So a lot of corporations down, a lot of companies. Now, this isn't just for irrigation. This is actually industrial. This is actually plumbing. It's across the board, straight across. And that's the most wonderful thing, especially for like California. California's getting really big with that because, of course, we're in the drought situation. Once you put the pipe in the ground, we know
Great.
never going to see it again, right? Hopefully.
We're the contractor.
Well, if you follow my instructions, put it this way, I like to say my boss actually has a pass-fail rate because, of course, we know how many people because the samples are sent in, how many people pass and how many people actually fail that I've actually trained. And we try to keep our percentage level to like less than 3%. So that's like 3 people in every 100 after they've been trained would actually fail the test.
Wow.
All right, so that's actually a pretty good ratio actually because you get in different factors, and I call it the CSI lab out there. That's if you guys are listening. That's what they do out there. That they'll take they take the failure and they cut it apart. They chop it apart. They shave it apart, and then they tell you exactly why you failed. They'll say, guess what? And the number one reason, not enough cement on the pipe. A lot of people think when you put the pipe, you're cementing the pipe to the fitting. All right, that you got to put a lot of cement on the inside of that fitting. You don't have to. You want to go light to medium on the inside, and I'll explain why in just a couple seconds, right? Because if you put a real lot on the inside there, you push this, you're going to take that cement, you're going to push it where?
Forward.
To the other side, and that's solvent cements. What did I just say solvents do? They
melts.
Melt and evaporate. So what's it doing over here?
Melting.
Exactly. So it's melting your pipe. Now, if you have an elbow, right, and you put it in the elbow, which I can flick up to that one in just a little bit, and I'll show you. But anyway, in the elbow, you're pushing it one way, you're pushing it the other way, and you're pushing it 3 ways. Where's it ending up? Back over here in the very corner, right? Guess what's happening in that corner? It's having a melt.
It's melting.
It's a melt fest.
It has a meltdown.
It's having a meltdown. Exactly. Good. Really good, right?
Hey, I just thought too, the way I can remember melt and evaporate is just remember the acronym ME. Remember ME for melt and evaporate, M-E. Have you ever thought about that?
No, I've got to look in an encyclopedia to figure that one out.
I'll call our patent attorney. We'll cover that.
Well, no, because you say melt and evaporate, so
Me?
so
M-E, so
M-E,
it's me.
Yeah,
Oh, very,
which is
very good.
melt and evaporate.
Melt and evaporate,
So you
right.
can use that at your next training.
And thank you very much.
Because that's how I'm going to remember. I could never remember melt and evaporate. You know, I always called it glue, but it's not glue.
Right.
Because you're melting.
So, you're right, exactly. And well, that means that you're always going to remember me.
There you go. I will remember you.
See how that works? All right. So with that, we'll get on. So number one, guys, make sure that you guys are looking for the right cement. We do on our website. We have a chart on our website that actually has the different size.
Is that weldon.com? Your website?
Yes.
Okay.
Yes. I'm going to try and flick up here, people at home. Yeah, I got to pick it up a little bit here. There you go. This is just an agenda that we typically go over. When we come out to your place, we go through basic principles of solvent welding, the proper techniques of solvent welding, the importance of the right size applicators, set and cure times. We do solvent welding tips, causes of failed joints. We do repair, and then we go through safety precautions. That's really big. We're really big on safety. Then we make, of course, the samples. That's our hands-on demonstration. And then the completion cards, when the cards come out about maybe 4 weeks, because you got 2 weeks to wait till they, test the samples, and then about a week to make the cards up, because these aren't like little paper cards. These are actually real cards. Mm-hmm. And then, of course, they're from the East Coast, so they get sent snail mail. So it takes about 4 weeks to actually get them. Anyway, let me get
Hey, but
this
that's
up here.
faster than when you do a rebate out in California for irrigation rebates. So
Yeah, pretty much. This is, of course, a little bit about well done, which we already went over. But I do want to let you guys know, though, that our formulations are low VOC. We're really big on that. In fact, we worked many years ago with the EPA itself to actually set some of the standards that are actually right there. In fact, I think Fabio may have told you that. We were there from the very beginning on working with getting that low. Okay. In fact. I don't know if you can see that. That's actually the new product that we got out. Oops, sorry about that. It's empty. It's real light. It's our cement light.
this is called. I was looking at the label for the first time in my life, at the back label.
Right.
And the 905 EC is the
ECO.
ECO.
It's our eco, right?
Eco line, but it's blue. It's blue color.
Yep.
But it's low volatility, low.
Yes, people get confused when they talk about the VOC, all right? There's two different kind of VOCs. There's a VOC that's the content that's inside the can itself, and there's also a VOC emissions. The VOC emissions is what you really should be more how should I say, more aware of. That's when you open up the can, the amount of emissions that you get inside your face, that you get inside the workplace, that you get, say if you're inside inside here, inside the studio, and you're to open this up. If this is a regular can of a regular product, the regular solvent cement product, a normal, typical 7-Eleven or what have you, okay? And you open that up, and you probably wait about maybe 5 minutes. You go, whoa, man, that stuff's like nasty, right? But the ECO, this actually has more than 30%, way more than 30% less. How do you do that? That's awesome. We've done something really different with the manufacturing and to get the same results. You guys are going to see with the ECO is actually going to have a line that's going to come out, and it's going to change the plumbing world. We're looking with the EPA to help people's workplaces be a lot friendlier and a lot safer.
So if a contractor is interested in doing their part to reduce pollution or contaminants in the air, the ECO line would be a perfect choice.
Yes, sir. And the number one thing to me is who is working with the can. To me, I'm a very safety-oriented person. Very. I make sure the guys even aren't making our samples. A few times I'll catch a guy without having his glasses on, and I'll stop him right away. I'm like, "What are you doing?"
From your perspective in the irrigation world,
yes.
Do you see? Let's take home builders, for example. Do you think more of them are going to start to require their contractors to use this kind of stuff and be certified to do that? Because they're all telling how they build these eco-friendly homes, and they have the low VOCs in the walls and the the Energy Star and the water.
We have LEED. That's LEED. That's what LEED is for. You know what LEED is, right? You've heard, right? For building. That would actually be, I'm sure, part of the connection for that. And I mean, if you are worried about the world, this is the stuff to go to. Myself being a contractor from Chicago I'm actually from Chicago for 47 years. Contractor also for quite a few years there, and believe it or not, for quite a few years, I was putting together pipe wrong, and so were the people that worked for me. And myself as a regular contractor, I would definitely get this. I'm not saying it's just because I work for Well Done. I'm saying that because guess what? If I actually worked with this stuff, had this stuff open, and I mean the difference is just crazy.
And you turned out normal.
Was that? Yeah, right, exactly. My wife would beg to differ. So. But she's a sweetheart, though. So that's Hannah. Thank you, Hannah, for standing by me. That's for sure. She's a good girl. So, but anyway, let's get on with this. I got all my shout-outs out. I'll probably get hit in the head by my wife. Well, you didn't mention me. But no, she's all right.
No, we got to call her. No, just kidding.
And there you go. Right. Ask her what her name is. Okay. All right. But
no, you can't stay at my house tonight either.
I got a rental, right? They don't care what it smells like when I bring it back, I guess. B.O., there you go. Anyway, let's get back to what we're talking about here. So our products are, most of our products are NSF, which of course is sanitary. When you see the NSF mark, you're going to know that that's going to be able to, because the water that touches this stuff, you think, hey, the cement smells like this. The cement, do you actually want the water that goes over this? Do you want to be able to, to drink that? I mean, you go, oh my gosh, to smell this stuff. I don't want to drink.
And what happens over time with all the water and the pressure that goes over it and over it? Does it start to come off?
Depends on actually how much is on the inside, I'm sure. How solid it is on the inside. If you actually put the pipe together the correct way, there will be none on the inside because you bevel your pipe. If you bevel your pipe, and I'll explain to you a little bit if we don't make this a two-part session, that beveling your pipe will actually save that. And if, like I said, it was mentioned, if you use just a light to medium coat on the inside of that fitting, where you're not going to have cement to push it forward. So you wouldn't have to worry about how long you have to wait for that to come out. The big thing is, though, the water that is running over it, though. Our products, we do a lot of testing with the NSF. In fact, our product here is NSF 14. That's, in other words, you can the water that goes over, you're able to drink it. So that's one of the good things. Okay. Anyway, and of course the Uniform Plumbing Code and of course the Canadian standards as well. Our products meet that, and of course the ASTM. That's the big one right there. That's the guys that do the step-by-step procedures. Well, they make us do step-by-step, and I'll tell you what, from being inside research and development, those guys really make sure we are on our toes. So there's no game plan. And one thing I'll tell you about well done. I never worked for a company before that didn't try to chintz out on their product or try to find really cheap materials to put them in and still charge. A lot of companies do that. They try and hey, guess what? We're trying to find a way cheaper and get the same standard out of it. We don't. We keep it straightforward. We keep the product real, and that's when I go home every day, I'm like, yeah, that's actually pretty cool. I like working for a company that does that. But so anyway, let's get on here, right? The seminars actually. I can't read that, but actually pretty much it just tells you that guess what? The failures are pretty much the number one reason for failures is actually due to lack of knowledge, which we just already talked about. And we're going to get to this next page right here. This page and the next page, you can see the first page, really first we'll talk about viscosities. There's 4 different kind of viscosities when you guys are looking for a cement, of course, and you guys probably see that when you guys will start looking, of course, at the cans, right? You're going to see that there's regular, medium, heavy, and extra heavy, okay? Regular viscosity is almost like a water. The extra heavy is like a tomato paste. You know what a tomato paste is, right? When you guys don't eat at McDonald's every night, right?
Not every night.
Not every night. So we got like a tomato paste. So if you were to have a half-inch pipe, I got a half-inch pipe right here and a half-inch fitting. All right, if you take that pipe and you put that pipe in here, how much space do we have in here? There's nothing, right? So what viscosity would you use?
Probably
regular.
The regular, exactly. The water, the regular, right? Okay. Now here's something about the pipe.
So it's nothing to do with temperature. The environmental temperature drives the choice. In other words, of what viscosity you use. It really has to do with the physical product that you're trying to use it on.
Yes.
Gotcha.
Somewhat, yes. Okay. Somewhat. I'll explain that in just a little bit because the heavier viscosity will buy you a little bit more time if it's hot outside. Okay.
Gotcha.
Now here's a 2-inch pipe. If you take the 2-inch pipe, put that on the inside of the fitting. You hear it? Now you got some more room. So you would actually use a little bit higher than more like a medium, okay? Now if you were to do a 10-inch or a 12-inch pipe, figure this, the larger the pipe, the larger the fitting, the larger, exactly, the bigger the crack that you're gonna have to fill, okay? And that gives you that much room so you can actually get the pipe in there. I mean, imagine having a 10 or a 12-inch pipe and having this much room to put it in. Right. Okay, it's just not gonna work. Now here's something really good is if for some reason you were out in the field and you didn't have a can of say regular viscosity, but you had a can of heavy or extra heavy, you can go ahead and use that in here. That's fine because guess what? It's a cement. It's going to fill in there. It's going to be fine. I wouldn't say do the entire job with it, but in case you needed to, say you had to get the pressure back up and you had to get the person's lawn back up and running, you can do that and come back after a period of preventive maintenance and mark it down for maintenance, come back and fix it. That's fine, but you can actually use that. But here's the big thing. You can't go the opposite way with this. In other words, you can't take like the 12-inch pipe and you can't use the regular viscosity because what's going to happen is the water's going to do what? It's going to roll around and it's going to come right back out. So that's why you really need to know about the viscosities, okay? And then next.
But in general, if with irrigation where you're going to, let's say I'm a homeowner, I'm going to be dealing with probably 1 inch and 3/4 inch and half-inch.
Yes.
And there I can go with the regular viscosity.
Pretty much.
Would be.
Okay. Yes. In fact, on our website, you can also see we have in fact, during the break, we'll get you on one of these things right here. This is actually a book that we actually bring out. This is our product guide, and our product guide here is actually
and that could be downloaded from your website, right?
Yeah, yes. I don't know if this whole
Product
thing is
guide.
downloaded.
I'll
It's downloadable,
double-check.
what it does though, it's an awesome website. First of all, but anyway. that's actually on the next page I wanted to show you. So we'll get to that next page here. You guys are going to see, the guys that are actually watching anyway, if you aren't watching, you guys can picture this in your head. Up a little bit, there you go. You can see that on this slide right here, all right, on one side, you have all of the inches, starting with 1/2 inch, and it goes up to 30. And then on the other side, you'll see that we have PVC cements, CPVC cements, ABS, and so on and so forth, okay? Anyway, what you want to do is you want to use your finger, take your finger, of course, run it down to exactly where it says. So you can see like 2-inch PVC, right? Look how many different kinds of cements you can use. There's industrial grade, there's specialty cements, all right, heavy body cements, medium body cements. There's a whole different line of products for just 2-inch that you could use. So what you do is in this book, and we pass these books out during our training, all right, so everybody actually gets one of these books. Every single product that we have is actually in this book. Now, this is the same thing online as well. All right, you pick your size, all right? And I'll tell you every single thing about it. Is it industrial? All right. Is it water? Is it water resistant? Is it chemical resistant? Is it water resistant? Go figure on that one. Is it water resistant? What's up with that? But anyways, is it chemical resistant? There's tons of reasons, and there's tons of different. I want to say things. The temperature outside. That's when you actually start getting into the temperatures as well. Okay. How do you want? Do you want a fast-setting cement? Do you want something that's going to be slow? If you're working out and it's say 95 degrees outside and the wind's blowing at 30 miles an hour, what's going to happen when you put that primer of cement on there? You're going to turn around, sneeze, come back, and it's going to be dry already, right? So if you use a heavier cement, guess what? It's going to buy you that little bit of more time. All right. Well, that's also if you use the right dauber, you won't have that issue either. So I just want to get you guys a little bit more paired up on being able to find the right cement. And that's really big going forward with what we're doing. Okay. So let's get on to this next one here. Okay. This is my stop and think time, I call it in my class. Okay. Is primer a cleaner? Yes or no? What do you think?
I'm gonna have to say yes. You're going to have to make a commitment, Rob.
Yeah.
I just think it puts another clean layer on.
Primer is not a cleaner. Why is that? Why is that? That is because we got a can. We'll call this the imaginary can. Well, it's not imaginary, it's in my hand. But it'll be whatever I say. Right now it'll be primer, okay? We'll take that primer. We'll take this dirty pipe right here. Take that primer out of that can, put it on that dirty pipe, take all that dirt, and where am I putting it?
Back in the can.
Back in the can. I just contaminated that entire can. I'm not going to know now when you take that out, where are you going to put that next? That's crazy. All right? We have purple and we have clear primer. All right? It's the same thing. P70 clear, P70 purple, same stuff. It's just purple. P68 clear, P68. It's the same stuff, just purple. All right? What do you think the reason is? Why do we have purple and clear?
Well, I would say that when you're applying it to white pipe, the purple will let you see that you have a consistent application, and maybe there's a different color pipe where you want to see through.
Really, really good.
Except it's wrong.
No. Actually, you were right at the area. Okay. All right, so you could see it, but in mainline, so who could see it? The inspector. Oh, that's right. So we're going to go step by step procedure, right? This ASTM training that you guys are getting. One of the steps on this is primering the pipe. So if you have that card and you're out on the job, and this is spec'd into a job, guess what? There's going to be an inspector out there. He's going to be walking around looking. He's going to want to see some purple out there to make sure you guys primer that pipe.
So when you ask me the question, is it a cleaner? To me, I maybe took that to the next level, saying, okay, I would assume that somebody cleaned the pipe first, and then they applied the primer, which then has a cleaner or a better surface before they put on the cement.
Well, the primer has to be wet when you put the cement on. So if they did it before you did, then odds are 99.999% that it's dry.
Do you feel that most people in the irrigation business put a primer on a 1/2 inch or 3/4 inch pipe, or even a 1 inch before they do it, or they just put the PVC cement on and just go for it.
I've heard some stories actually of some companies that thought that they would save time by having their guys, and they have a big job to do on Monday, so they'll have their guys come in on Saturday and prime the pipe.
Oh,
so,
no.
Yes, sir.
Are you kidding me?
Yes. And this is not a joke. This is actually serious, and this is a few companies actually. But of course, it's the lack of knowledge. Is what it is. I'm not going to shout out and say, hey, guess what? These guys are stupid. No, because guess what?
It's ignorance.
Education, exactly,
right.
and that's what it's all about. These guys are nice guys, are hardworking guys. It's just about, hey, guess what? And
that's the purpose of these shows
Yes.
here. We bring we try to be jovial and fun and stuff like that. But there's also a seriousness to this because people are paying money to have things installed, or developers are paying big money for contractors to come in and do the job.
Right.
And like you said, they want to do it right.
Yep.
That's important. It's reputation and everything else. So
Exactly. So looking at the time here, I want to get cruise liner. So anyway, the reason is purple, of course. The last thing I just put on there, I put down, it was kind of a joke kind of to me because I had some idiots back in, not that idiots, I say idiots, guys that worked for me back in Chicago. They called me up and said, hey, how do you clean up purple primer? I said, why? I said, hold on, what job are you on? They're like, the hot tub. I'm like, don't even tell me. I said, you're not even supposed to be using purple. So yeah, I had to pay for a new hot tub and a hearth and a floor. Because so I figured if somebody out there knows, like one of those things where, hey, you put a half a cup of Dawn dishwashing liquid, some vinegar together, mix it together. Well, if you have that, call here, we can retire. Okay, I know a really good chemist at work, Andreas Schneider. He can fix anything, and we could retire. Trust me. Bring it on in. Let's see now. Okay, and we'll get past that. So much for my little joke there. All right. This is Now this is something I'm going to go back on. Okay. Because I was going to ask you guys, but I'll let you guys in on a secret here. This pipe is round, right?
Yep.
That fitting, this is not round. Fittings are not round. Do you know that? They're actually conical. Do you see on that picture right there? Wider on the outside, tighter on the inside. All right? In America, we have what they call, in America. Isn't this kind of crazy? I have when we do these classes, and we have guys that have been doing this for 30, 35 years, sitting back with their arms crossed like, what are you going to teach me?
I hope
at the end of the class, they come up there going,
I hope the people are listening. I didn't mean to inject here, but I hope the people are listening tune into www.kcaaradio.com and watch this, because it's one thing to hear it.
Yes.
But a picture's worth 1,000 words.
Yes, I've taken all the pictures you see up there. I've taken, and I've made sure that the average Joe can take a look at this and put it together. Not lines all over the place. Not something you got to seriously look at. I mean, you can see obviously that it's wider on the outside and tighter on the inside. Okay, well that's not for a reason, because this is what they call, in America, we have what they call interference fit piping system. Did you ever think? Because I mean, whenever you take this pipe, you take the pipe, you put the pipe into the fitting, it never goes all the way down to the bottom. Why is that? You're not the most unluckiest person in the world ever. There has to be a reason for that, right? You think, you know what? And sometimes a lot of people think, hey, guess what? That's all I got to do is take that fitting, pop that on her, and I don't have to worry about it because it's a non-pressure line or something. You don't want to do that, first of all. Anyway, you got to figure this. Now we want to get this pipe, right? Here's a cut-up fitting, right? Just like you got up there. This pipe is supposed to stop 1/3 to 2/3 of the way in there. Now there's a reason for that, right? That bottom 1/3 down here, we want to get that pipe down there, right? How are we going to get that pipe down there? How about if we melt the pipe and we melt the inside of the fitting?
It opens it up.
It's going to make it slippery, right? If it makes it slippery, this pipe's going to come down. Then you're going to melt this, right? So now what we do is, and first of all, people, here's the proper way to primer. And this is one thing that really freaks people out. You see people out there, they take that imaginary can of primer right there. They take the primer, they go like this with it. Nice little coat on the inside of the fitting, nice little coat on the outside, color it really nice so it's nice and purple. That's totally wrong. You want to melt the inside of that fitting and the outside of that pipe. You want to get that pipe all the way down there. By painting it, making it look pretty, that's not going to do anything, right? So what you're actually supposed to do, you're supposed to take that primer, take that fitting, and scrub it. By the way, you see how I'm holding, you guys that are watching? I'm actually holding that dauber up by the stem, not by the cap, because you want to take that primer and scrub that primer. When you're scrubbing that, you're going to start to feel the dauber drag. Once the dauber starts to drag, the material right here is starting to what? It's starting,
melt.
It's starting to get the melted plastic on the inside is starting to make this stick, right? So now we got the inside melted. We do the same thing to the outside of the pipe, all right? We do the same thing. We scrub it, keep scrubbing it, right, until it starts to drag on us, all right?
And how long a time do you usually have? Because I
Well,
know sometimes that stuff gets really sticky and hard and glues.
Well, here's the point. Remember I said that the primer has to be wet when you put the cement on, okay? What temperature is it outside? And what dauber are you using? It's a huge market. I said this might have to be a two-part show here, all right? Because first of all, if it's hot outside, and if you're to put primer on with this right here, not to jump to primers or nothing, but if you had a 4-inch, this is about a 4-inch can right here, okay? All right, if it's 95 degrees outside and the wind's blowing 30 miles an hour, Santa Ana winds, right? Are you going to use something like this? If now that you know that you got to keep the primer wet, are you going to use something like this? No, you're not at all. In fact, there's a common rule that we actually have is half the diameter of the pipe. But I always say, sure, you can follow the half the diameter of the pipe as the size of the dauber that you need, but what's the conditions you're working in? Okay, we have what they call a super dauber or super swab, all right? This thing actually comes out, comes apart. You can actually make it even larger if you want. It fits into gallon cans, and it also fits inside the quart cans. But yeah, it's actually invented by Jack Roach and Terry McPherson. Actually, the two guys are actually, like I said, they're really smart guys. So was that. But anyway, now this right here, here's a 4-inch. If it's 95 degrees outside or 90 degrees, 30-mile-an-hour wind, now what would happen if you took this with that primer? Voila, you're done, right? So it all depends on what you're using your brain, what size dauber you use versus the temperature outside to what you're doing.
So
you got to keep that wet. Everything has to remain wet.
So does yours product in the can, when I open it up, does it have a dauber inside of it?
Yes, I know. Even though it says brush inside.
Okay.
You're going to hit me with that? A lot of people ask me about that. It says brush inside on it. Why doesn't it say dauber? It should say dauber in can, right?
Yeah.
How come it doesn't say that? I don't know. I still haven't gotten the answer back. I asked my boss. I'm like, why does it say brush? And he says, I don't know. Let me go take it.
Because maybe the extra letters wouldn't fit on that.
I thought about that. There's only one more letter. See, D-A-U-B-E-R. There's only one more. I already thought about that. I'm like, that would have been fine in there. But I have maybe, I don't know, dollar.
So just because that comes in here doesn't mean that's the proper one to use.
Exactly, guys. Exactly. Very, very good, Rob. Very good. Exactly. Just because whatever's on the inside of that can may not meet with the criteria you need, which is the pipe you're doing and the temperature that you're doing.
Certainly want to work on the 30-inch pipe.
So here, I want to get to this really good part because I'm watching this. Oh, you guys got to check this out because this is the most coolest part. Now, this is where my mouth actually dropped open when I first took this. Fabio Castellani was the first guy to actually he took me and he was the guy that actually taught me this stuff. All right, back then. I'm looking at the guy. I'm sitting in a room almost like this with my mouth open, looking at me. He's like, "Are you okay?" I'm like, I'm just wondering how many callbacks I got from Chicago because this is crazy. All right, now, remember I told you we melted the inside of the fitting.
Right.
We melted the outside of this pipe. All right. If this, I'll do it like this. I'll give you my best YMCA. How's that? Here's the fitting right here. All right. This is the pipe stop right here. Here's the pipe. We're going to get this pipe, and we want this pipe to get stuck down here, right to 2/3, right? We want it to come all the way down. So we melt plastic. We got this melted all plastic here, melted plastic, right? Melted plastic out here. When we put this pipe in, what are those two melted plastics doing? They're blending together, aren't they? They're right? Exactly. So now that they're blending together, they're welding themselves together. Because first of all, what does solvent do? Melts. And then what?
Evaporates.
Exactly. So it melted, right? It comes down here. Now what's going to happen when the solvent evaporates? What are you going to have right here? This is going to be one piece.
Yep.
It's a solid piece. You welded this whole fitting to this whole pipe. That's why it's solvent cements. All right. So now this bottom third right here, that bottom third, we just push that pipe in all the way, right? In fact, you guys out there in TV land, there you go. You can obviously see this right where it says tighter on the inside. Now, we melted the inside of this fitting that you guys are looking at, okay? We melted the pipe. The pipe comes on the inside, right? It's nice and slippery, slips down to the bottom. That bottom 1/3 down there, okay? That's right where everything melts together and it touches each other, and then evaporation happens, and you just welded that whole bottom 1/3, right? Here's something really scary. That part down there, the bottom 1/3, does 80% of your weld. 80%. Now, if that does 80% of your weld down there, that 1/3, what happens if your pipe's not cut straight? Oh my gosh. Is that nuts? Look at the picture. When I took this picture, yeah. I took it with a pipe that's not cut square. Take a look at that 80% mark. All right?
When you cut, well, that's another thing. there's different ways to cut the pipe. They sell in the stores, well, you can do it with a hacksaw.
Right.
They have these little tiny ones, little hacksaws that you can cut. They have the tools that you squeeze and do.
Oh, the ratchet.
Yeah. So sometimes they cut straight, especially with the hacksaws. They don't always cut straight.
No, the sawzalls either. Guys out there with the electric sawzalls.
Right.
Yeah, you got to be really careful with that, guys. You got to make sure you're hitting your mark. You got to make sure. In fact, what you guys see right now, I actually just took that picture today in a hotel room and actually got it on there because I know that I wouldn't be able to lift up a sample.
That wasn't the leg of the chair from your hotel room, was it?
No, it's actually the bed. Right, exactly. So right now my sheets are probably stuck together from the cement and purple from the primer. The maid's gonna wonder what the heck I was doing in there. But you can see right here what I did is this is the sample I typically pass around. And for you guys that I have to fly out to, you guys know that I spend like 20 extra minutes at the or at the airport because TSA really doesn't like me taking pipe samples around with me. They get kind of leery about that. But I do it because of you guys. I want you guys to make sure you guys know what's going on here, right? I mean, why give you guys half a show here? All right, so you can see the one on the left side. That's a pipe that's cut square. Look at that 80%, right? The bottom 1/3. Look at that 100% coverage. Now take a look at the one that's on the right. How much of that 80% are you missing by just having a cut?
Almost looks like a third, maybe, or 25%, maybe.
Yeah, I'm going to raise the bar here. What happens when you take that pipe and you push that pipe in, and you hold it in for as long as you think you need to hold it in, and you let go of it, and it's not? What happens?
Comes out.
The pipe starts to slip out. Okay, now what's happening to that bottom 1/3?
Yeah,
oh my gosh! All right, and here's the picture. Guess what, Mr. Sample Guy over here.
So that means I shouldn't give it a little quarter turn at the very end when I insert the pipe into the fitting.
That's
straight, or do I do it?
Believe it or not, that is it's kind of an optional kind of thing. I've actually heard and read and been told, of course, that because there's sometimes that especially landscapers, these guys might be down in the ground in an angle in the dirt in an area where they can't turn it a quarter turn. Okay, if you put the proper amount of cement on the outside of that pipe, okay, and you push that pipe in straight, all right, and you end up with a bead that's all the way around the outside, you're good to go, and I'll explain that, like I said, in a fast little bit. But I'm going to get back to this here real quick, right?
Okay, go ahead.
Right, when that pushes out, look at the 80%. Is that
I can see where they can't twist it because I know when I'm fixing pipe and it's buried in the ground, it's ½ inch. Unless you dig up 5 feet on either direction, and if you're doing if you're adding a coupling, you're fixing it, you're adding a coupling, you can't twist it because the other end's connected.
Right, but now here's a weird thing. Now once you start getting into stuff like this, all right, you start getting like say the CPVC, the Corazan, stuff like that. You have to check, especially on the bigger jobs. You want to check with the material or the pipe manufacturer, all right? Because sometimes in some jobs it's spec'd in, and guess what? It may be even spec'd in that you must turn a quarter turn. If they yes, I know it's kind of weird. So there's a yes and there's a no. It's kind of weird. If you're to me though, it's using your brain is the best. If you can't turn it, make the best of it. Put the proper amount on the pipe. And as long as you get that, if you get a bead that's all the way around the outside after you get done putting that together, that means you put enough cement on there to actually go in, hit that spot, that 80% spot, right where that weld's at. And guess what? The rest of the cement's going to go what? It's going to come back because it can't go in far. When it comes back, it fills all the voids, and it ends up as that bead that's out here, right? You want to wipe that bead off, of course. I'll tell you why, right? But anyway, that's if you put enough cement on that pipe going forward, you're good to go. You really don't have to turn it. In fact, even on the screens, it even says turn a quarter turn, if possible.
Okay, so if I'm working with Schedule 40 pipe, has a certain thickness.
Right.
Okay. Now I wouldn't use it, but say now somebody's using Schedule 120.
Right.
Totally different.
Class 120.
Okay.
Right.
And if you do this, quote, melt process, what's going to happen because the thicknesses are different? Can you overdo it? Can you over melt it?
Can you, well, the amount of, you're talking about how much cement you can put on. Well, see, the gap's going to be different, though. The gap that you're going to have between the fitting and the pipe is going to vary as well, though. So manufacturer-wise, they're only going to give you enough. And, of course, if you do your homework on what cement you're going to use, no, what's on the inside here, there shouldn't be too much. You should be just fine. All right. So are we going to go on that?
Yep.
Okay, excellent. All right. So what we're going to do next is we're going to, now that we know that that 1/3 at the bottom is nice and welded together, right? All right, now we're going to talk about the fill, that fill part in the back. That's where the cement comes in, okay? That's when we're going to start putting the cement in. We got to put the cement there. People ask me all the time, well, why don't they just make the fitting smaller then if we only have to worry about that bottom 1/3? Well, we wouldn't have any structure support on the pipe. If you had a 10-foot pipe and you had a fitting that's only this big, right? Guess what? Your pipe's going to be going like this, okay? So that's why they have pipes this size, or the fittings this size. All right, so now we got to put cement on the inside of that. All right, the cement pretty much, guess what? PVC starts off with little tiny pellets, okay, plastic pellets, which is, of course is plastic, right? And what they do is they take this and they put it in a reactor. This is like a 101 kind of thing, okay? So they actually take the PVC beads, all right? They put it with solvent. Solvent does what? Melts and evaporates. So exactly, so they put it in a reactor. They spin it, right? So all the plastic beads, they start turning into a slurry, right? Guess what's in here?
The slurry?
The slurry. That's right. The slurry's in here. Right? Kind of good. But anyway, so guess what? That's actually, we're going to put it in. So now if you guys can see that crack right there, if we put cement on the inside there, we're going to complete that. We're going to have the weld at the top, all right? And the back's going to be filled, which we call the bonding. Now we're going to bond it because it's not welded. So we're going to actually bond the wall of the fitting to the pipe. So there's actually no gluing. So there's no more glue word. I'll say glue about 3 or 4 times and I'll slap my own hand. Okay. So now here's the big thing. Okay, here's the big thing about cementing now, guys. What you want to do is this. People cement all wrong. Remember we were talking about that earlier? About people put too much cement on the inside here. Right? You want to go light to medium on the inside of that fitting. Where you want to go heavy is on the pipe. You want to make sure that you put a nice thick coat. Actually, we're going to put 2 coats on. Right? We're going to put 2 coats on the outside of this. The right way to do this is actually put a cement on a pipe, light coat on the inside of the fitting, and again, another heavy coat on the outside of that pipe. Okay, since we're running out of time here really quickly, instead of going through these slides, I know we started getting off track here a little bit. Pictures
We're just going to have you back, that's all.
I can come back if you guys want me back. That'll be fine.
No, this is good. I mean,
what's that?
No, learning about all this. Yes. Most people, like I said, don't understand.
Yeah, if you guys like to have me back, I'll definitely come back anytime you guys want. But really quickly, that way you guys can do your project this weekend as well. All right. So what we actually got to do is with the primer. Now we know that the primer, right? We want to melt that the fitting, right? The fitting is actually harder than the pipe because it's injection molded. Okay, I could go over that. I go over that in class 2 on how pipes made, how fittings made. Probably one of you guys that does that because I don't know.
The pipe's extruded and the PVC.
Pipe, yes, sir. Pipe's extruded and this is injection molded. So this I can explain to you why it's even shinier than the pipe and all that kind of stuff. People use sandpaper. Do not use sandpaper. It's bad. Now you guys know. Guess what? What does that do when you use the primer? It melts the inside. What's this doing is taking all the sand off that you just put in there. You're going to put it back in your can.
I see you use steel wool to go around too.
Then you got steel fibers in there.
Right.
Because now you guys know the primer melts, right? So it's going to obviously melt there, right? So you know more. You don't need now you guys know what it does, right? So, but anyway, this is harder. The fitting is harder. So you want to start off. I always remember FF, fitting first. Okay. So you take your primer, all right? After you got your cut pipe, your cut square, okay? And we got to put a bevel on it too. You guys want to go over what the bevel is? How much time we got?
Yeah. No, go ahead. You got 2 minutes.
Okay, great. All right, the bevel needs to be on there because guess what, guys? If you don't have a bevel on it, you guys are going to have a straight 90 on the end of that pipe. So that means no matter how much cement, no matter how much at all, how much cement you put on the inside of that fitting, when you put this in,
it's going to be pushed.
It's going to be pushed to the other side like a snowplow, right? So you put that bevel on there. As you're pushing it, it's actually taking the cement and it's pushing it against the wall of the pipe, which actually like gets up here and it gets sent back.
What's the quickest way to do the bevel?
There's actually right here. This is actually a tool. This is my favorite tool. We don't make this.
A bevel tool?
This is a bevel. Yeah, this is called a DEB4. It's made by Reed. We don't actually sell. We actually have different. We actually, if you go to our website, we do sell different kind of beveling devices, of course.
I never saw that.
Yeah, this is actually this is kind of fun actually. It goes up to 4 inches. You take your 2-inch, snap it in, twist it. There's like a little shaving that comes out like a pencil sharpener. And voila, it's even at code because this is, if you read the back of the can, it says 10 to 15 degrees for your bevel. This is already set 10 to 15 degrees. So now you got that beveled, right? So you want to take your pipe really fast, cut that pipe nice and square. Of course, we know why, right? Bevel your pipe, right? You want to make sure it's nice and clean after that and everything.
So would you bevel even at like a 3/4 inch and 1 inch schedule?
Oh, yes, sir.
Yeah?
Yes, sir.
Okay.
Yes, sir. All right. I
Oh
guess
my
we'll be back.
gosh.
We'll finish up, right?
Yeah, sorry we asked you so many questions at the beginning, but
Don't worry.
maybe we can bring it back on via phone or next time you're out in this part of the woods. But it's been so helpful.
I will come back. If you guys want me back, let them know. I'll come back.
Well,
We can finish this
remember
off.
when you write into the IA or contact them, you give them WZ-3, William Zulu-3, so they show that you participated in this. And we will bring you back because this is a whole science that I didn't know about this other
bevel tool.
Yes, and if you're interested in having us out to come out and train you guys, you can contact the show, and then they'll contact us, and we'll gladly come out and give you guys the whole.
Mike Grabowski from Well Done. Thanks a lot.
You're the pro.
Thanks, guys.
Right.
PVC Cement Pro.
Good night, everybody.
KCAA Loma Linda, 1050 AM, 106.5 FM, and now 102.3 FM.
Now,